Hi, we have come to a new chapter that is on indices. Today we are going to cover the basic rules of indices. Now, the first rule that perhaps every one of you already know. A to the power of m is A times A times A altogether m times of it. Alright, this is denoted by A to the power m. Alright, there's no reason why this is so. This is just like my name is John Leong. Alright, there's no reason why. Okay. Now, how about rule number 2? I shall use a different color. A to the power of minus 1 is equals to 1 over A. There's no reason for this also. Alright, it's just a rule and people decided to name it this way. What is rule number 3? Rule number 3 is the nth root of A is written as A to the power of 1 over m. Now, there's no reason for this. It's also just a name. It's just like a name, alright? Now, but what does that mean? Give you an example. Fifth root of 32. Now, how to find the fifth root of 32 and what does that mean? That means you want to find a number A that times itself 5 times. 1, 2, 3, 4, 5. And that number must give you 32. And if you try the number 2, 2 times 2 times 2 times 2 times 2 will give you 32. So this answer is 2. I give you another example. Now, square root of 64. What is square root of 64? Now, all of you already know that it is 8. Now, so you are actually trying to find a number that times itself 2 times. And your answer is 64. So this answer, the A is 8. So this answer is 8. That is what I meant by nth root of A. Now, how about rules number 4? Now, rules number 4, A to the power of m times A to the power of n is equals to A to the power of m plus n. Now, there's a reason why this is so. The rest of the rules mainly uses these 3 rules to prove. Alright, so the rest of the rules, there's a reason why. The first 3 rules, there's no reason. It is just like that. People decided to call it this way. Now, why this is so? Now, A to the power m times A to the power n means this A to the power m is A times A times A m times. Alright, then you multiply by A times A dot 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 times A n times. Okay, so all in all, you will have A to the power of m plus n. Okay. Now, rule number 5. A to the power m over A to the power n. Now this one means what? This is also can also be written as a to the power m divided by a to the power of n. Now this is equals to a to the power m minus n. Now why is this so? Look at this, okay? Now so this is a times a times a over a times a times a. How many terms are there over here? There are m terms. Alright, whereas this, you have n terms. Alright, you learn in set 1, you can cancel if they are the same. Alright, you can cancel. So how many remaining? There will be m minus n remaining. Alright, because here got m, here got n, then you cancel. Below, you're left with 1. Alright, so the top will still left m minus n of a. So your final answer will be a to the power of m minus n. This actually comes from rule number 1. Rule number 4 also is derived from rule number 1. Rule number 6. A to the power m to the power n. This is equals to a to the power m times n. Now why is this so? Now a to the power m is a times a times a m times. Alright? And then you repeat itself. Okay, this group it repeat itself. Alright, another m times. And then another m times. All together, it repeats itself how many times? Another m times. All together, there are n of it. Alright, so this will be equals to a to the power m times n, because here you have m times n times. Okay. Now the last rule, there is rule 7. Maybe I write it over here. A to the power of 0 is 1. Now why a to the power of 0 is 1? Now let me give you an example. A to the power of a. What is a to the power of a? You know that a to the power of a is 1. But a is to the power of 1. So if you follow rule number 5, alright, this will be equals to a to the power of 1 minus 1. So this is a to the power of 0. And you know that this answer is 1. So a to the power of 0 have to be 1. Alright? I would like to show you what are the common mistakes and pointers when you are dealing with indices. Now the first common mistake that students make is, for example, a lot of them will write this is equals to 9. Now this is wrong. Okay, this shouldn't be equals to 9. Now remember one thing is this index here only applies to the number that is next to it. Now 3 is next to the index, so it should be 3 squared. Alright, so minus 3 squared, so it should be minus 9. Alright, and this should be equals to minus 9 because 3 is beside the square. Now however, if it's written this way, alright, then the answer is 9. Now likewise, 5 to the power of 0 is 1. So some of you may think that 5a to the power of 0 is 1. No, this is not 1. Alright, this is not 1. But this is 5. Now, another common mistakes that student will make is, take for example, 3 to the power of minus 2. Some student will think that this minus is same as minus 3 to the power of 2. No. This negative has nothing to do with the polarity of the number. It doesn't change the polarity of the number. This means 1 over 3 squared. Okay? Now, next I would like to touch on the important pointers. Now you will come across things like 3, 4 to the power of x plus 2. Now this one can be simplified as into 3 squared, 3 to the power of 4x, and that is equals to 9 times 3 to the power of 4x. Now, why I say this is important is because if I write 8 squared, 8 to the power of 2x, many of you will know that this is equals to 8 to the power of 2x plus 2. You are familiar changing from this form to this form. Now we are working backwards, so you are not familiar with it. Alright, this is so it's important to know both ways, or changing from here to here or from the other way back to this form. Okay. Now likewise, maybe I use a different color. Maybe orange. 3 to the power of 4x minus 2. This will be equals to 3 to the power of 4x over 9. Okay. Now another important pointer is, now 3 to the power of 2x. This is the same as 3 to the power of x times x squared. Alright, because 2x is same as x times 2. Alright, so you can take the 2 and put it outside the bracket. It's the same. Alright. Now another pointer is a to the power of minus m over n. Now, which one must you do first? Alright, minus the negative first, or the n first, or the m first. It doesn't matter which one you do first. Alright, it will still give you the same answer. Now, I give you an example. 8 to the power of minus 2/3. Now let us do the negative first. So this will be 1 over 8 to the power of 2/3. There's no change to the numerator when you do to the power of 2/3 to 1 is still 1. Now, so you are left with 1 over 8 to the power of 1 over 8 to the power of 2/3. Now, so let's say if we do the cube root first, it will be 2. Then you square it, so this will be 1 over 4. Okay? Now let's try doing the square first. If you do the square first, alright, the 2, the index 2, so it's a square, so it will be 64. minus to the power of minus 1/3. Now, up to you to do which one first. Let's say we do the negative first. So will be 1 over 64 to the power of 1/3. Now, to the power of 1/3 is cube root of 64. Alright, so you got 1 over 4. Now you can play with it if you want to do the square first and things. I leave that to you. Alright, so when you have this kind of expression, it's up to you to do which one first. For me, I would like to do the negative first, followed by the root. That means followed by the denominator, and then I square. The reason is I don't like a negative. The next thing I hate is this number is so big. Alright, so I like to reduce it first. But it's really up to you. Alright, we have come to the end of this chapter. Thank you for watching. If you like our video, please press the subscribe button and have a nice day.